Welcome back, everyone. This is 6.5, graphing quadratic functions. Before we go into the problems, there's some properties you need to know. So if you are given an equation that says f of x equals x squared, this is called the parent function. First thing I notice, also, we have a parent function. Notice that there is a value here in front of that x, which is a value of 1, which means it's a positive. So if you see a positive 1 at the beginning, means the parabola, that's what a quadratic is, opens up. The other thing, since it has an exponent power of 2, means there are 2 solutions, which are 2 x values. Now, if they gave you an f of x equaling x squared plus k, this is known as a vertical shift. The k is the y value. Moving up or down. If we have f of x equaling parentheses x minus h squared, this is a horizontal shift. The h means it's moving the x value left or right. It's going to be opposite the sign inside. And then if you see it as f of x equal to x minus h squared plus k, this is known as your quadratic function in vertex form. So notice that all these possibilities are positive values at the beginning, which means they're opening up. So if there was a negative at the beginning, then they would open down. Starting with our examples, give me 1 second. So the first example, it says, let f of x equal x squared. It says, if g of x is the graph of f of x shifted down 5 units, write the formula. So first thing, it's a shifted down, so it means this is a vertical shift. Remember, the equation for the parent of a vertical shift is x squared plus k. Since it's a shift down 5 units, y equals x squared minus 5. And that would be your equation. If we were to graph it on the graphing calculator and show the difference, so you're going to go y equals. If you have anything in the input, hit it clear. So we're going to do the first one. The parent function said x squared. So I'm going to go x caret 2. Now we're doing a shift 5 down. So you can either do x caret 2 or x hit the square key. It'll give you the square key. Put minus 5. So we're going to have the original, which is the parent, and then the shift. Hit enter and then graph. So there's my original, and then this is your vertical shift down 5 units from the parent. So this is what you're seeing. On the next example, it says let f of x equal x squared. If g of x is the graph of f of x, shifted left 4 units, write the formula. So remember, these are your horizontal shifts, which the equation said y equaled x minus the h squared is the setup. Now, if you want your graph to go to the left 4 units, it needs to be the opposite of the sign. So remember, if I do x minus h set equal to 0, I get x equal to positive h. If I want it to be a negative, I'm going to write x equals negative 4 units, because that's what I want to move. If I move the x over, I become x plus 4 equal to 0. So my equation now becomes y equals x plus 4 squared. So we're going to do that into the graph again. You're going to go to the y equals key. We already have the parent function of x squared. Just arrow down, hit clear for that one. go parentheses, x, now go plus 4, close it, square it. Hit enter and then graph. So our parent function is here at the origin, and it's shifted to the left 4 units now because it's now going, remember it said it's going to the left 4 units. On the next example, so they want us to, here they want us to graph y equals 3 parentheses x plus 1 squared minus 4. So now in this one, this is here's our vertex form where they gave us a value of 3 here in front of it, which means this is a narrow, makes it a narrow graph because it's a whole number, which means the graph is going to be very close to that y-axis. So another way of doing it, if you want, so we have y equals, I'm going to make the parent function 3x squared. That's my parent function. Then the next one says it wants it to be y equals 3 parentheses x plus 1 squared minus 4. So if you're trying to graph it without a graphing calculator, you can use the first equation using a t-table. And you're going to pick the values -1, 0, 1. It's easiest to pick those values. So if I take -1 and squared, I become +1 times 3 makes it 3. Plug in 0, I'm still 0. 1 squared is still 1 times 3 is 3. So this is our parent function. It's at -1, +3, 0, 0, 1, 3. So this is our parent function. What it does is now from that parent function, we have a +1, -4, which means I'm going to the left 1 unit, down 4, because remember, it's the opposite sign. So if it's +1, it becomes negative. If it's -4 on the outside, the vertical pieces is just whatever the sign is, that's what it goes. So we're going to shift the origin point to the left 1, down 4. This one to the left 1, down 4. Left 1, down 4. So when we see our new graph, you should see that shift. So in the calculator, if you go to y equals, hit clear to both. We're going to put the parent function now that's going to be 3x squared in the first line. And then it's going to be 3 parentheses x plus 1 close squared minus 4. So make sure that your equations are right and you don't make a mistake. When we hit graph, so here's our parent function, which matches the one we just graphed, and then the shift, which is vertex form, is shifted to the left 1 and down 4 from where it was, which matches the one that we hand sketched. On the next one, it says they gave you the graph of the function f of x is given below. So we see it's at the origin. Then they gave us another graph, which is our g of x, and they want us to write an expression for it. So when we look at the situation here, here's our parent graph. If we look at our points, we have -1, -1, 1, 0, 0, 1, 1. So -1, 1, 0, 0, 1. I'm just sketching it down here so I can see my rough sketch to see what's going on. We shifted to the right, +1 unit, and the vertex, the y value went up 2 units. So that's telling us that our equation is y equaled. Now, if I'm going to the right, I am minus because I want to be the opposite of the sign. Remember, opposite sign inside. So if I'm negative, I become positive. Negative became a +1. It's a +2, I'm a +2. So now to verify if this is our correct equation, try it in the graphing calculator. So parent function, go y equals again, clear both, go up. We're going to go x squared for the first line, but that was our parent function. The second one says x minus 1, so I'm going to write x minus 1 close squared plus 2. hit enter, hit graph. Parent function and our change. And if you look at our change is right where it needs to be. Next example. So in this one, they gave us a transformation of the function f of x squared. It says, right, the first thing I noticed about it, when it's y equal to x squared, that is a parabola opening up. But this one is a parabola opening down. So the first thing, this is going to be a reflection, which means y equals negative x squared is our parent function in this instance. So now let's look at our situation. So this is where we were originally, negative 1, 1, 1, 0, 0. Because remember, we're normally the other way. This is our normal graph down here. We went, the vertex went all the way to negative 3 here. We went 3 units to the left, and we were 3 units up. So if we have y equals x minus h squared plus k is our vertex equation, we're going to the left 3 units, so I'm going to write y equals x minus a minus 3 squared plus 3. Well, minus means plus, so x plus 3 squared plus 3. Remember, if I'm positive on the inside, I come out negative on the outside. So to verify your equation, go to the y equals, clear both. Now write, remember, you use a little negative key, not the minus sign, the negative key. Then put x squared for the first line. Now type in the second equation that we just came up with. X plus 3 squared plus 3. And then hit graph. So there's our original. And what's different between this one? When I typed it in, forgot my little negative sign here. You need to make sure you put your negative there. So it goes negative value. So I'm going to go second insert, a little minus key, hit enter, and now your both equations are opening down and matches the one that's given to you. So let's reiterate. Remember, y equals x squared opens up, y equals negative x squared opens down. I call this here a bowl of soup. This is a rainbow, if you're trying to remember which type of parabola you have. Other things about it, if it's a y equal to x squared, you're going to have, if it's y equal to x squared, you're going to have 2 x-intercepts, which means it crosses the x-axis twice. You're going to have 1 y-intercept. Same for both, y equal to negative x squared. The only time it will be floating, a floating graph, with no x-intercepts is due to imaginary values. So an example would be, an example of that sort would be y equals x squared plus 1, because it was at the parent function. So your graph normally would be here. It's hitting the x-axis. So I have 1 x-intercept in this instance. If I have it floating up 1 unit, it will never cross the x-axis. This is where we have imaginary answers. You can have 2 x-intercepts. Say it was a vertical shift down from it. Now I shifted down. Now we cross the x-axis in 2 points. Now if we had it opening down and it shifted negatively more, here's where we have imaginary answers. If we shifted it up, now you have 2 x-intercepts. You will always hit the y-axis regardless. The only time you will not hit the y-axis is never, because even with a vertical and horizontal shift, you will eventually hit the y-axis at one point or other.